Om Ganeshaya Namaha.
Introduction. The die casting machine. Die casting machine is very complex. It consists of mechanical, electrical, hydraulic and safety systems that must all work together. Die casting machine systems. The die casting machine is made up of several systems. Each system contains specific components. The die casting machine's systems are structural, electrical, hydraulic, safety. Structural components. The structural components are the framework of the machine, similar to the skeleton in the body. These components carry and support all the other machine components. The main purpose of the die casting machine base is to support the major die casting machine components. Its shape is generally a rectangular box and usually extends under the entire die casting machine. On some very large die casting machines, the base may only support the back of the die casting machine, and a separate support used for the front. Many die casting machine manufacturers enclose the rear portion of the die casting machine base to form a steel tank. This tank becomes a reservoir for the hydraulic fluid/oil that powers the die casting machine. When the die casting machine runs, it generates heat. This heat goes into the oil, raising the oil temperature. For safe operation, oil temperature should not exceed 120 F. If it gets too hot, it can't lose its lubricity and fire resistance. In addition, the oil must be kept clean to operate efficiently. The reservoir is equipped with a thermometer to check oil temperature, and a sight glass to check the oil level/cleanliness. The rear of the die casting machine is the end of the die casting machine where the closing or clamping mechanism is located. This is generally where the electrical utilities, motors, and pumps are located. The front of the die casting machine is where the injection mechanism or shot end is located. The die casting machine base must be strong enough to support the clamp and shot ends without sagging. The die casting machine must be properly mounted to be level, straight and square to avoid sagging or twisting. Platens. The platens are the three large plates that carry the die casting machine loads, and they rest on the die casting machine base. They are called the stationary platen, moving platen, and rear platen. Stationary platen. The stationary platen, located at the front of the die casting machine, holds the stationary die half on the die space side. The shot mechanism, either an 8-frame or 8C frame, is mounted to the other side. Moving platen. The moving platen is located between the stationary and rear platens. The moving or ejector half of the die is mounted to the moving platen on the die space side. Rear platen. The rear platen is located at the rear of the die casting machine. The moving and rear platens are resting on shoes that slide on replaceable wear plates. The wear plates are mounted to the die casting machine base. Both the moving and rear platens move every cycle. The moving platen slides back and forth to open and close the die. The rear platen slides back and forth as the tie bars stretch and relax. The rear platen is also known as the adjustable platen due to its movement to accommodate die height thickness adjustment. Tie bars. A typical die casting machine has 4 tie bars. The tie bars are long, round, solid beams mounted through the 4 corners of the platens. They are used to hold the die casting machine together. The moving platen actually slides along the tie bars. Strength and size. The size and strength of the tie bars determines the size of the die casting machine. Every cycle the tie bars actually stretch to develop the force that is necessary to hold the die closed against the force of injection. If the die casting machine is improperly set up or somehow the tie bar becomes overstressed, it is possible to break the tie bar. Toggle mechanism. The toggle mechanism connects the rear and moving platens to each other. This mechanism may look different depending upon the die casting machine manufacturer, but it always performs the same function. Toggle mechanism development. It takes a great deal of force to stretch the tie bars and lock the die casting machine. If this were to be accomplished with a hydraulic cylinder, the cylinder required would be very large and move slowly because of the large amount of oil that would be required. Indeed, some older die casting machines in the 1940s did have very large cylinders. Die casting machine engineers developed the toggle mechanism to overcome the deficiencies of using a large cylinder. The toggles act as levers and gain the mechanical advantage during die close and locking. This allows the use of smaller closing cylinders that can operate at higher speeds. The toggle mechanism is also referred to as a linkage, because it links the rear and moving platens. Electrical components. Electrical energy is used to power and control the die casting machine. The electric power is converted to hydraulic energy in order to do the actual work of the die casting machine. Electric motor. An electric motor or motors provide the power for the die casting machine. The motor is directly coupled to the hydraulic pump. Electrical energy is converted into hydraulic energy when the electric motor spins the hydraulic pumps. The pumps force oil into the hydraulic lines under pressure. Location. The motor is located at rear of the die casting machine, adjacent to the reservoir. Also, at the rear of the die casting machine is an electric power cabinet that encloses the motor starters and the die casting machine control logic. A disconnect switch is mounted on the outside of this panel along with provisions to lock out the machine when necessary. The motor heads operate at high voltage, typically 440 over 480 volts. This area must be kept clean and dry in order to avoid an electric shock hazard. The couplings between the motor and pump must be guarded because these rotate at high speed and could cause injury if contacted. Solenoids. Solenoids are used to shift the valves that control the volume and direction of hydraulic oil flow. The solenoid flash valves are relatively robust but should not be abused. Limit switches. Limit switches are the sensors, the eyes and ears, of the electrical control system. They are located in many different places on the die casting machine. They are used to sense the position of doors, guards, cylinders and other moving components on the die casting machine. Safe operation. Their maintenance is essential to the safe operation of the die casting machine. Limit switches must never be defeated or tied back. Broken connectors and exposed wiring at limit switches should be repaired immediately in order to assure safe operation of the die casting machine. The trip rods or actuating mechanisms at the limit switch create pinch points. The die casting machine may also have other types of switches and sensors. Some of the limit switch functions may be accomplished with proximity switches. There may be pressure switches that react to a given level of hydraulic pressure. Hydraulic system components. The die casting machine is operated by a hydraulic system. This means that a fluid, fire-resistant oil is used to power the cylinders that make the die casting machine move. This hydraulic system operates at high pressures and high flow rates. The hydraulic fluid is hot and can cause burns. Leaks and spills should be repaired and cleaned up quickly. These not only waste costly oil but also can cause slippery surfaces that could result in injuries if someone slips and falls. Pumps. The die casting machine typically has two hydraulic pumps. One pump is capable of providing oil at high pressures but in low volumes. A second pump is capable of providing a high volume of oil at low pressures. For example, The pumping capabilities of a 400-ton die casting machine may be 8 gallons per minute of 2000 psi oil from the high-pressure pump and 40 gal/minute of 40 psi oil from the low-pressure pump. This type of pumping capability is used to solve the various demands of the die casting machine. The die close cylinder requires a large amount of oil to open and close the moving platen. Once the die face is close, only a small volume of high-pressure oil is required to stretch the tie bars and lock the die. Just the act of closing requires the output of both pumps. Filter airs are required to keep the hydraulic fluid clean. The filtered airs are located at the outlet of the pumps to assure that clean oil is sent to the various valves and cylinders. Maintenance. The filters require routine maintenance to make sure they work properly. Most filters have a visual differential pressure gauge on them that should be checked to make sure that the oil is clean. Small dirt particles in the oil can cause valves to fail because of the small clearances in the valves. Valves are used to control the amount and direction of oil flow. Solenoid-operated valves are used to direct the flow to the head or rod side of a cylinder, or they may direct oil to shift a large valve, such as the pilot-operated check valve at the base of the accumulator. Some of the valves may be manually operated. For example, the valves controlling the speeds of injection or die closing may be fitted with large hand wheels. These valves are used to control the oil flow rate or to shut off the oil flow. On more modern die casting machines, the speed control of die casting machine functions is controlled by a series of valves mounted on a manifold. The manifold provides a centrally located source of hydraulic fluid for the speed control valves. Heat exchanger. Most die casting machines have a heat exchanger. This is a large tubular tank located adjacent to the reservoir. It operates similarly to a boiler. Hot hydraulic oil and cooling water run through the heat exchanger. The water cools the oil. Leakage in the heat exchanger can be troublesome. Hydraulic oil could be contaminated by water, or the cooling water could be contaminated by the hydraulic fluid. If hydraulic oil temperature is excessive, the operation of the heat exchanger should be checked. Hydraulic cylinders. Hydraulic cylinders are used to open and close the die casting machine, inject the metal into the die. They also may be used to operate the ejection system, move slides on the die, actuate the safety ratchet, and open and close the safety door at the die parting line. These cylinders may be oil or air operated. Die close, ejection and shot cylinders. The die close cylinder is used to open and close the die. Some die casting machines have cylinders to actuate the ejection system on the die. The shot cylinder is used to inject the metal into the die. Injection components. The hot chamber injection components include the shot cylinder, plunger coupling, plunger, rings, gooseneck, bushing and nozzle. An A-frame that is attached to the stationary Platen supports all these components. These components inject the metal into the die. The cold chamber components include the shot cylinder, plunger rod and tip, coupling, and the cold chamber. Accumulator. The accumulator is simply a large steel tank. This tank is partially filled with hydraulic oil. Above the oil is nitrogen gas. An accumulator is used when a large volume of oil is required. This could be during die open or close, or during injection and intensification. Intensifier. The intensifier is a hydraulic device that increases the hydraulic fluid pressure at the end of the injection stroke. The purpose of this high pressure is to dramatically increase the metal pressure in order to squeeze additional metal into the die cavity as the metal shrinks, and to further compress trapped gases. Safety components. The die casting workplace has many hazards associated with it. Everyone must be aware of the hazards and work safely. The die casting machine operates with high pressures, high forces, and high voltages using liquid metal at high temperatures. To operate safely in this hazardous environment, the die casting machine is equipped with a number of safety devices. Die space area. The die space area, the area where the casting die is mounted, is protected by safety doors or gates. These devices prevent access to this area when the die casting machine closes and remains closed during a portion of the overall die casting machine cycle. Guards are located at the toggle mechanism to prevent access to this mechanism when the die casting machine is operating. Safety ratchet. Many die casting machines are equipped with a safety ratchet. This device prevents the die casting machine closing. The die casting machine will only close if numerous safety conditions have been met and the ratchet dog is withdrawn. Summary. Each die casting machine consists of several systems. Structural. The structural system and its components form the basis of the machine, providing support. Electrical. The electrical systems and its components provide power to the machine and control it. Hydraulic. The hydraulic system and its components use a fluid, fire-resistant oil to power the cylinders that make the die casting machine move. Safety. The safety components help prevent injuries and accidents while using the machine, when used appropriately and coupled with safety-conscious actions.
Welcome to Steady Die Casting Software. Great news for you, we launch software with the name of SDS Cast 1.0, through which you can make your die casting process easy. In this software you can use 6 tools: die design, filling time calculation, high pressure die casting machine parameter calculation, plunger speed versus valve round. You can do process validation, and most unique tool PQ square analysis. In the die design tool you can easily calculate tonnage capacity of the machine by just putting few input values, and after one click you will get all design values. Just like that, here you can calculate the short weight. You can design your plunger diameter, runner, gate area. You can also validate your gate area, and one more interesting thing you can do is that you can save or print each and every output report. Now in the filling time calculation tool you can calculate your specific cavity filling time. Only you have to do is just put few things as per your casting application. Some of the constant you can select from the available table. Next tool is HPDC machine parameter calculation, through which you can calculate short volume, fast injection position, intensification start position, injection high speed, injection slow speed, gate velocity, filling ratio, intensification pressure, and many more other important parameters you can calculate with a single click. In the plunger speed versus valve round tool you can generate a graph in which you can find how many valves round you have to open to get the desired plunger speed. This kind of tool, only available at SDS Cast 1.0 software. Process validation tool, very useful to validate your process. This is a short or less time consuming validation of your machine and die's design parameter. In this tool you can validate the process for an up to the 3000 ton machine. Tool of this software is complete PQ square analysis. By entering a few inputs you can do a complete PQ square analysis. Not much complex calculation required to do this analysis. In this tool you can do analysis for zinc alloys, aluminum alloy, and magnesium alloys. That is the uniqueness of this tool. By single click you can draw a complete PQ square diagram. And you can select your process parameter as per your casting application. Full guideline assistance available for SDS Cast 1.0 software. First time in die casting history these kinds of die casting problem solving software available globally. Thank you very much. Keep learning till death.